So I'd like to start this video off by thanking everyone for the great support that video number 1 received. It seems to have been helpful for some people, and that's the goal of this whole series of videos, so I'm really happy about that. So let's get started with part number 2. Let's start with a little recap here. Last time, this is basically where we ended. We had lined up our panel outline with our panel foundation in Front Panel Designer. We then exported 2 separate image files, one with reference points and one without. We also got a glimpse of what the panel looks like immediately after importing it into Kicad and looking at it under the 3D viewer. So here we are opening up Kicad. The first thing we're going to do is start a new project. So go File, New Project, and just go ahead and name it. Put the folder wherever you want, name it something you'll remember. I think I had already made a folder, so I'm just using the one I'd already made in my Kicad projects folder. And then go ahead and open up the file listed next to the green PCB symbol, and that will open up the PCBnew portion of Kicad, which is what we're going to be using right now. I just want to take a minute and mention a couple of things about PCBnew that are important before we get started. I urge you to take my advice on this one. The first thing you should do when you open up PCBnew is click on the Kicad menu, which is in the top left side of the upper menu bar, and go to Preferences. Now notice the all-important autosave feature. Don't make the same mistake as me. Put that in a ridiculously low number so you will ensure that you do not lose hours worth of work if something happens. Then you can happily move on with your day and make some panels. And while I am dropping some Kicad knowledge bombs on you, I'm also just going to point out quickly where to find the 3D viewer. Go to the top menu bar, click View, and then underneath that, 1, 2, 3, 4 spaces down, you'll see 3D viewer, and that's where you're going to go to view your panel as you progress through the creation. And it's a really cool feature that I like a lot. And to get your image file from Front Panel Designer into Kicad, you're going to do a couple different steps here. So first you're going to click File, then go down to Import, then Import Graphics. In this window will pop up here, and you're going to browse for your files where you saved the Front Panel Designer files, as you can see me doing here. So these next couple of steps are important to get yourself started on the right foot here. So you're going to have those 2 files with references and without. So we're clicking on the one that has with references right now, and it's important right here to make sure that you're putting it on the DWGS user layer. I import the reference file onto the DWGS user layer because it acts simply as a guide or a sort of outline, but it doesn't actually show up on the finished product panel. So anything you put on that layer you can see in PCBnew, but it won't show up on the finished product. So take a look at my mouse pointer here. We're going to do a similar process here. File, Import, Graphics. Now we're going to choose the file that does not have the reference points, and this is important. We're going to put it on the Edge Cuts layer. So go ahead and use that drop down menu there where the arrow is, choose Edge Cut Layers and hit OK. So now you have 2 outlines here. The one on the user layer that won't show up on the final product to use as references and to help you line things up appropriately, as it has those plus signs right in the middle of the drill holes, as I mentioned in video 1. And then on the edge cuts layer, that's the actual outline of the panel that you're going to make. So that's where the cuts would be from the manufacturer to actually create your panel. So now you have both of those in PCBnew, and the goal here is going to be to line these up perfectly on top of each other, and that's what I'm doing here in the video. zoom way in, and I want to point out something that's going to make your life a lot easier. If you see where that arrow is, that is the drop down menu to choose the grid sizing. Um, you'll notice that the components that you put in PCBnew will snap to the grid automatically, but when you're trying to get very fine adjustments, you want to make that grid very small so it allows you to almost seamlessly move things without kind of snapping to bigger intervals. Now make sure to inspect your work and satisfy your obsessive compulsive disorder. Make sure this is perfect. And now here we're looking at the 3D viewer from PCBnew, admiring our work here. Looks great, looks like a panel for a Eurorack module. Everything looks pretty lined up and even, and I love looking at the 3D viewer. All right, now back to work. And here's another shameless plug for the autosave feature. Don't forget. For those of you not familiar with Kicad or PCBnew, one important feature that you need to be familiar with is called footprints. Footprints in PCBnew represent physical components that you will put onto your panel, for instance, drill holes, mounting holes, etc. Step number one for creating footprints is to create a folder for you to save them in, and then tell PCBnew where to find that folder so it can find your footprints. So navigate to your location of choice, create a folder, and name it something that you'll remember. Follow my mouse pointer there on top, click Preferences, Manage Footprint Libraries, and then you're going to click Add, put a name for the folder, scroll over, hit that little folder button, go and find the folder you just made. Double click or click and then OK, and then now PCBnew knows where that folder is, and you are able to now save your own footprints in that folder and pull them up. So what the hell does this all mean? Where the hell is that folder? How do I find it? Those are all very valid questions that I will answer shortly. See the arrow pointer there on my screen. You're going to click on that little icon there. It looks like a 6-pin IC or something. That's your footprint icon. So you're going to click on that and then click on the black background there in Kicad, and that will bring up your footprint library loading screen that you see there. And once you get past that loading screen, then this menu will pop up, and this is the footprint selection menu essentially. Now let's go create and edit some footprints. So you're going to click on that same footprint icon, but this time up in the top menu bar there. And now this is your edit footprints interface. So if you scroll down, this menu is in alphabetical order. You should be able to find the folder that we just created where you're going to store your own personal footprints. Speaking of footprints, I'm going to take this time right now to show you how to create and or edit your footprints. So I am partial to the sort of elongated oval shaped Eurorack mounting holes. So that's what I'm going to show you how to create right here, and then I can briefly show you how to do just the regular old round hole. Luckily, it's right there. You can see it on the screen there. The Eurorack mounting screws are typically like M3 screws, so you can use just simply an M3 mounting hole in PCBnew, and that should work just fine. Sometimes, like I said earlier, I might go in and edit it and increase the size a little bit, just maybe by 1/10 of a millimeter or so, just to give the PCB manufacturer some leeway. And if you want to create these exact elongated oval shaped mounting holes, just follow what I'm doing on the screen and type in exactly what I type in, and that will give you the appropriate size hole. And I've used this exact hole for many panels and it works perfectly fine. So just copy exactly what's on the screen there, and you'll end up with this guy. Click OK. There you have it, a functional Eurorack mounting hole. I just want to point out something really quick. You see that little reference REF there that I just clicked on? And as you use Kicad and PCBnew, the colors of different icons and things will start making more sense to you. But the light sort of teal color tells me that that is on the front silk screen layer. So I want to change that here because prior to saving the footprint, because otherwise every time you put the Eurorack mounting hole on your panel, you're going to get the REF star in the front silk screen, which is where you put all the labels and everything. So you want to mouse over the reference letters, click on it, hit E to bring up the edit field, and clicking that checkbox next to visible will make it so you can still see the reference REF lettering, but it won't show up on your actual panel. The white usually represents the user layers, and those, as we talked about earlier, don't actually show up on the printing of your panel. I want to touch on the concept of anchor points here in PCBnew. This will become very important later when we go to actually place the mounting holes, because you want the holes to line up with the screw holes on your rails. This means you need them spaced correctly as well as placed in the right location on the panel so they sit right on top of the respective rail screw holes. In PCBnew, the anchor points really have to do with a component's placement on the grid. The grid in Kicad is based on the XY coordinate system. Remember this from high school? I know I don't. Anyways, this becomes very helpful when moving components to exact locations. The one caveat to the Kicad coordinate system is that somebody thought it was a great idea to reverse the y-axis. So up is negative and down is positive. The x-axis remains the same, where moving right on the x-axis is positive and left is negative. So what's the big deal with anchor points, you appropriately ask? Setting an anchor point is telling Kicad where the 0 point is for that particular component. The 0 point essentially represents the origin point of your component. So if you need the center of a component, for example a drill hole, to be 7.5 millimeters to the right and 3 millimeters down from the edge of your panel, Kicad needs to know where it's measuring from. And this from is the anchor point. The anchor point can be anywhere. It can be the left side, the right side. It can be 1 millimeter in from the left corner if you want. But most of the stuff that I'm going to do here and show you, it's important to know where the middle of the component is, especially for the mounting holes for the Eurorack rails. So here I want to show you a little trick that I do. You see the blue line that goes from top to bottom and left to right, and that is sort of marking your the center of your component. It's kind of hard to see that center point where those two lines intersect. So what I usually do is change my grid size up. If you go to the top there in the grid drop down menu to about 25, and that allows you to snap to larger intervals on the grid, and just makes it easier to do a straight line when you don't need some fine movement. Now grab the straight line tool. It kind of looks like a square missing one side there. After you adjust your grid, now draw a straight line down from the top to the bottom past the center point of your component on a layer that you can see. And then you're going to do the same from right to left, using those blue lines in the background as your reference point. And that's going to give you right dead center in the middle of that component, as you can see. And now you can actually see it because it's in front of the component as opposed to behind it like the blue lines are. Next, what you're going to do is go over to the right side menu bar, hit that anchor icon, and bring that that plus sign down and put it right over the center of your component, marked by the two lines that you just drew. And then all you got to do is click, and that sets the center point right in the middle. From there, you're just going to delete those lines that you drew, and then you're done. Sort of done. We still need to save this component, so I'm going to show you how to do that right now. So go ahead and click File, Save As. Now we're going to name the footprint and choose the appropriate folder from the list below and click Save. And now take a look at the left side of the screen there. You can see the folder that I created highlighted, as well as the footprint that we just created saved into that folder. Cool, so now you have your own custom footprint for Kicad. Now it's time to start placing footprints on your panel, and to do this we're going to use the grid coordinate system like we spoke about before, and we're also going to see the purpose of setting anchor points for your footprints. In doing so, we'll see how this allows you to place different components precisely on your panel right where you want them to be. This is the standard that we're going to be using in regard to measurements for placement of the mounting holes. Now I would like to demonstrate how I get the rail mounting holes positioned in the correct spot on the panel. As long as you have your anchor point set to the middle of the footprint, this process can work with any type of mounting hole, be it oval like this one here or round. This process can also work with any other footprint, provided you know where the footprint should be placed in relation to the edge of the panel or another component on the panel. Now if you take a look at the screen, you'll see that I have selected the footprint and clicked the M key. You may also notice that the point at which this footprint is selected is the predefined anchor point we chose earlier. The way I get these holes exactly where I want is by taking into consideration those measurements from the previous image, which is from the Doepfer A100 DIY page, which I highly recommend everyone checks out if you're into DIY. So I know from these measurements that the center of the rail mounting hole needs to be 7.5 millimeters in from the edge of the panel and 3 millimeters down from the top of the panel, or 3 millimeters up from the bottom of the panel. We also need to remember that PCBnew reversed the y-axis for some reason, so keep that in mind when placing footprints. On the screen you will see that I've zoomed into the mounting hole footprint and have lined the center of the hole with the edge and top of the panel. This is one place where having those long white line indicators come in really handy. Once you are satisfied that your footprint is lined up with the edge of the panel, click the mouse to place it at that spot. From there you want to hit Command M on a Mac or Control M on Windows, which will bring up the Move Item window. Since the center of your footprint is lined up nicely with the top and edge of the panel, you can now move this footprint exactly where you want it. In the Move X box, type 7.5, and the Move Y box, type 3. Then click OK, and you should now see a mounting hole whose center point is exactly 7.5 millimeters to the right of the edge of the panel and 3 millimeters down from the top of the panel. And now we're going to repeat that process for the bottom rail mounting hole. The only real difference, since you're still on the left side of the panel, the x-axis is going to be the same, so it's still going to be 7.5 to the right, but this time you're going to want to go up in the y-axis, so you're going to do -3. And for panels that may need more than 2 rail mounting holes, it's the same process. You just have to remember that you're going to the left on the x-axis now instead of the right, and then the up and down on the y-axis as we discussed, but it's the same process overall. Now let's click into the 3D viewer and admire our work. We should all be very proud of ourselves. So I think 20 minutes is about enough for this video, but I feel like we covered quite a bit in that time frame. We talked about creating footprints in PCBnew, including making your own Eurorack rail mounting holes. We talked about saving footprints. We talked about finding those footprints that you save and editing them. And then we also discussed the coordinate grid a little bit, and how to move your footprints exactly where you want them. So all of these things that we've talked about so far are all gonna kind of add up to us creating the final product, because in the next video, when we start looking at images, how to bring images into this, how to position those, all of the stuff we just learned is going to be super helpful. So I just want to say I really thank everybody for taking the time to watch these videos. I really hope they're helpful, because that is the main goal of this series of videos, is just to get more people familiar with the process of creating Eurorack panels, which is super fun. So I hope it was helpful. Please consider liking and subscribing if they were helpful to you, and I'll see you in the next video.